Authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled The Future of Low-Dose Radiation Research. I now recognize myself for 5 minutes for an opening statement. Good morning. Welcome to today's Energy Subcommittee hearing. Today we will examine the status of U.S. research in low-dose radiation and explore the effects of the previous administration's agency-wide reduction in funding for this area of science. Last Congress, the Science Committee explored the Department of Energy's decision to terminate the low-dose radiation research program, which, until its closure in 2016, was one of the largest and most effective programs in the world. In the course of staff briefings on this decision, a DOE employee was fired for speaking out in support of the low-dose radiation research program. While this employee was eventually reinstated as a result of committee oversight, the department has yet to restart this important area of research. The DOE's program explored the health impacts of low levels of radiation, allowing our nation's researchers, industry, and military to safely handle nuclear material, maintain the nation's nuclear weapons program, and dispose of nuclear waste. Low-dose radiation research can also inform the authorities who set nuclear safety standards for the public, enabling federal emergency response agencies to more accurately set evacuation zones from radiological incidents. This research is also particularly important to practicing physicians who rely on knowledge about the impact of low doses of radiation to decide when and how to use diagnostics to detect cancer in patients. This use-inspired basic research leads to scientific discoveries and long-term benefits for the energy industry as well as our national defense. Today's hearing is yet another opportunity to evaluate whether we as a nation are doing everything we can to ensure that the regulations, guidelines, and protections we put in place are indeed grounded in sound science. We know a lot about the relationship between adverse health effects and high doses of radiation. At high doses, the dosage and the risk are proportionally related, but the health risks associated with exposure to low doses of radiation are much more difficult to observe, and we are a long way away from understanding and accurately assessing this particular risk. In the absence of conclusive evidence, scientists use what's called the linear no-threshold, LNT, model to approximate the effects of low doses of radiation on the human body. This model takes what we know about high doses and applies it to low doses. Current federal dose limits and guidelines are based on that LNT model. Because this model is simply an assumption of the impact, not a validated mechanism for assigning risk, there is no definitive science to justify how many of our nation's nuclear safety procedures or to set guidelines for medical treatments. In order to best serve our nation's energy, medical, and defense needs, we need foundational research in the radiology and biology to directly define the impact of low doses of radiation. Here on the Science Committee, we hear a lot of enthusiasm for next-generation technologies, but we cannot forget about the questions we have left unanswered. The United States should not rely on a best approximation when it comes to our nuclear regulatory policies. DOE must reprioritize basic research in low-dose radiation so we know we are using the best available science to set these standards. I want to thank our accomplished panel in advance, our witnesses, for testifying today, and I look forward to a productive discussion about the future of American low-dose radiation research. I now recognize the ranking member, the gentleman, for his comments.
Thank you, Chairman Weber.
I'm sorry, you're right, the ranking member.
Well, yeah, I'm the ranking member pro tem, I believe.
I think that's what it is.
That works.
Yeah.
As well as, I guess, representing 100% of the PhD scientists in Congress. So,
yeah. There we go.
Anyway, well, I want to thank you for holding this hearing on a really very interesting and important topic. And thank you to all our witnesses for being here to provide us with your testimony and your expertise. I'm Congressman Bill Foster. So I'm a scientist and a businessman, so I understand the importance of regulatory costs and getting the answer right. This is an important issue because if you make the wrong decision or a decision not based on the best science, frankly, people can die. If you set too conservative thresholds for chest x-rays, then patients may have non-diagnosed conditions because of x-rays that are not taken. If you, for example, set too conservative standards for nuclear workers, then that may impose, or nuclear bystanders, that may impose large costs on the nuclear industry and cause us to shift our energy balance, for example, to coal, which we know kills tens of thousands of Americans each year. And so it's important to get this answer right. And the basis of our regulatory framework around radiation exposure has been the linear no threshold model, which I'm sure we'll hear all about today, and that says the risk of cancer and other bad effects increases with every incremental increase in radiation exposure. So this conservative approach to regulation is not fully justified by the current body of peer-reviewed scientific literature in the low-dose regime. And investing into this research in this field is not just about the development of regulations. It's all about public understanding of an important issue. Federal investments in radiobiology research have resulted in significant progress in our understanding of the health effects to low-dose radiation, in particular how cells respond to radiation exposure on a molecular level. During the past 17 years, low-dose radiation research program at the Department of Energy has been responsible for several notable shifts in how scientists examine the impacts of radiation exposure, including the impact on radiation not only on the cells directly, but directly deposited with energy, but on the cells surrounding them, the so-called bystander cells. There's also new technology that has become available. The use of big data, for example, to perform virtual experiments on large human populations to try to tease out the signal here. For example, gene sequencing of blood samples to detect cancer and precancerous cells at a preclinical level. This work has informed our physicians and medical researchers as they try to design better treatments for cancer patients. And moreover, the implication of this research can be seen in the number and the breadth of different federal agencies that are investing in this work. In addition to the Department of Energy, there have been federal investments in low-dose radiation research at the Nuclear Regulatory Commission, the FDA, the Environmental Protection Agency, and the National Institutes of Health, NASA, and the CDC. These agencies all see benefits from this work and in their own areas of interest. Yet, the leadership in DOE under the past administration, and I should note under the current Trump administration as well, has decided to no longer support this research. And I'm happy to join my majority colleagues with our questioning of this position. And we are not alone in our concerns. The GAO's report on this topic seemed very clear. They recommend that DOE take the lead in, quote, the development of a mechanism of interagency collaboration on research on low-dose radiation's health effects. And though I must observe that one of the glaring omissions from this hearing is a witness from the Department of Energy. We're reviewing a report from GAO that includes key recommendations for DOE, and it is sad that we're here without a representative from the department to provide us with their input on these recommendations. And it's really a missed opportunity. And I'm disappointed that we can't have a more complete conversation here and hopefully make real progress in our oversight of the department in this crucial area of research. I hope the majority will consider as we move forward with additional hearings on this topic or others directly under the purview of DOE. The department's lack of a Senate-confirmed leadership really shouldn't give them immunity from congressional oversight. And with that said, I'm looking forward to this bipartisan dialogue on an important topic. And thank you again, Mr. Chairman, and our witnesses.
I thank the ranking member pro tem, and now I'm going to introduce our witnesses. Our first witness today is Mr. John Neumann, Director of Science and Technology Issues at GAO. He manages and oversees both federal R&D programs and federal efforts to support innovation. Mr. Neumann received a bachelor's degree in political science from the State University of New York at Stony Brook, an MBA from American University, and a JD from Georgetown University. Our next witness is Dr. Gayle Woloschak. Am I saying that right? Okay. A professor of radiation oncology and radiology at Northwestern University. Additionally, Dr. Woloschak is a visiting scientist at the Bundeswehr. You sound almost German. Institute for Radiobiology in Munich, Germany, and a lecturer at Rosalind Franklin Medical School in North Chicago, and a visiting professor at Alexandria University in Alexandria, Egypt. And when do you sleep? She received a PhD in microbiology at the Medical College of Ohio, Toledo. Our last witness is Dr. James Brink, professor of radiology at Harvard Medical School and radiologist-in-chief at Massachusetts General Hospital. Dr. Brink was elected an honorary member of the American Association of Physicists in Medicine and a member of the International Society for Strategic Studies in Radiology. Previously, he served as the scientific vice president on the board of directors of the National Council for Radiation Protection. He received a bachelor's degree from Purdue University and an MD from Indiana University. Dr. Brink joins us today to testify in his capacity as the chairman of the American College of Radiology Board of Chancellors. I want to say thank you to all of y'all for being here, and we will begin our testimony, Mr. Neumann, by recognizing you for 5 minutes.
Chairman Weber, ranking member, and members of the subcommittee, thank you so much for the opportunity to be here today to discuss GAO's report on federal protections against the harmful effects of ionizing radiation and federal support for related research. To protect against cancer and other harmful effects associated with radiation exposure, the EPA, the NRC, and other federal agencies have established requirements and guidance that apply to a range of settings in which exposure can occur. Agencies such as the Department of Energy have also funded research to determine how low doses of radiation affect human health. However, uncertainties remain about these effects. For example, in 2016, the Department of Energy's Biological and Environmental Research Advisory Committee reported that further research on low-dose radiation could decrease uncertainty in cancer risk estimates. My statement today summarizes our report on low-dose radiation, which examined 2 areas. First, how selected federal agencies have developed and applied radiation protection requirements and guidance for workers and the public, and secondly, the extent to which federal agencies have funded and collaborated on research on the health effects of low-dose radiation. In our review of how federal agencies developed and applied radiation protection requirements, we focused on 4 settings in which radiation exposure can occur: the operation and decommissioning of nuclear power plants, the cleanup of sites with radiological contamination, the use of medical equipment that produces radiation, and lastly, the accidental or terrorism-related exposure to radiation. And we found that to develop radiation protection requirements and guidance for these 4 settings, agencies generally relied on the advice of scientific advisory bodies. And this advice included the use of the linear no-threshold model, which assumes that the risk of cancer increases with every incremental increase in radiation. However, advisory bodies have also recognized challenges in accurately estimating cancer risks from very low doses of radiation. For example, much of the data on health effects of radiation exposure come from non-U.S. populations, such as the Japanese atomic bomb survivors. These populations received a large exposure to radiation over a short time, and there is uncertainty about the extent to which the health effects for them can be extrapolated to a U.S. population that may be chronically exposed to low doses of radiation. In looking at federal agencies' support for research on the health effects of low-dose radiation, we found that 7 agencies obligated a total of about $210 million from fiscal year 2012 to 2016, but their collective annual funding has decreased by almost 50% over that period. We also found that agencies collaborated on particular research projects, but they did not collaborate to address overall research priorities, such as the research needs that the scientific advisory bodies we met with had identified regarding low-dose radiation health effects. Such research needs include areas related to uncertainties in the linear no-threshold model, and by extension, in the agency's dose limits and guidance levels that are based in part on that model. In the past, the Department of Energy provided leadership in this area. However, its leadership role has decreased since 2012, as the department phased out funding for its main research program on low-dose radiation health effects. We found that no other agency has stepped forward to fill this role. Given these findings, we recommended that the Department of Energy take the lead in developing a mechanism for interagency collaboration on low-dose radiation research. The department disagreed with our recommendation, stating that it would be inappropriate for it to lead because other agencies have their own budget authorities and research priorities. However, given the department's past leadership role, we continue to believe that the Department of Energy is in the best position to lead agencies in developing such a mechanism for addressing shared research priorities. Such an action would be consistent with the department's responsibilities under the Atomic Energy Act to conduct research related to nuclear energy, including the protection of health during activities that can result in radiation exposure. This concludes my prepared remarks. I'm happy to respond to any questions you may have.
Thank you, Ms. Neumann. Dr. Woloschak, you are recognized for 5 minutes. Thanks.
Okay, thank you. I'd like to mention that I used to work at Argonne National Laboratory at DOE facility as well. I think that's important to mention. I'm going to let some questions shape my discussion. So the first question I'm going to ask is, what is low-dose radiation? Before I describe what low-dose versus high-dose radiation means, I would like to remind everyone that ionizing radiation surrounds us daily. It is part of the natural background from sunlight and the Earth's crust, and radioactive chemical elements are present in what we eat, drink, and breathe, including this cup of water I just drank. All of this constitutes natural background radiation. Doses of radiation characterized as low-dose radiation are higher than natural background. Most often, low-dose radiation exposures occur when we are close to a nuclear cleanup site, or they might result from occupational or accidental exposures, or exposure to medical low-dose diagnostic procedures such as CT scans. Any of those low-dose exposures are thousands of times lower than the radiation therapy doses used to treat cancer patients. These therapy doses belong to the category of medium and high-dose radiation. So the next question is, what don't we know, and why don't we understand low-dose radiation? The most significant known risk from exposure to low-dose radiation is considered to be cancer. If I ask a room of radiation biologists, what is the risk for cancer formation from low doses of radiation, I get every answer possible. From a little bit of radiation is good for you, go sit in a radioactive spa and lap up those rays, to radiation risk for cancer decreases as the dose decreases, to risk from low doses is worse per unit dose than risk at high doses. So the question is, we don't actually know the precise relationship between low-dose radiation exposure and cancer induction. Why is there so much disagreement? Because we have contradictory data. One source of this problem is that many of the low-dose studies done in the past were performed with cells in a test tube. A direct leap from cells to humans is never done in medicine because it is just not accurate. Before clinical trials of any sort with drugs or with radiation, numerous animal studies are done in advance. In addition to the question of cancer risk, some of the recent low-dose studies in Europe, Japan, and China suggest that we may need to explore additional issues, such as risks to unborn, risks to newborns that may have different effects for central nervous system or cardiovascular system. Until we have more research, questions will remain. My next question is, why is closing the gap in understanding of paramount importance in the U.S.? And my response is, our radiation protection policies deal with low doses of radiation because that is precisely the level of environmental and occupational exposures that can and should be regulated. Radiation protection is designed for a healthy population with the view of preserving health. With regard to low-dose radiation, these policies are based on the assumptions we make about low-dose radiation effects. It is a matter of course that citizens must be protected from dangers associated with radiation exposure, but overprotection may be wastefully expensive and deplete funds that could be used for other strategic goals for the nation. Next question, what needs to be done in the research community to solve this issue? What was DOE's role in funding discoveries in the field? Work resulting from the DOE low-dose program led to many significant findings. For example, some unique biological responses to low-dose radiation were found that are not evident at high doses. This means that a simple extrapolation from high-dose to low-dose effects would not be correct. Much of this work was in the discovery phase and thus was done with cells in culture and never made its way to be tested in whole animals. This limits our ability to apply this work to human beings, which of course is our end goal. Since the time when the DOE low-dose program was terminated, biomedical science has continued to progress. New technologies have been developed and new discoveries have been made. Fine-tuned models could be developed to set the stage for fine-tuned decisions and evidence-based protection studies. Before the DOE low-dose program, DOE was the leader in the radiation research science worldwide. Large-scale animal studies were done ranging from low-dose occupational-type exposures to high-dose nuclear disaster-type exposures. I am in awe when I look at the volume, planning, design, and structure of these experiments done with animals for the entire duration of their lives. For reasons unknown to me, DOE terminated these studies without really completing a full analysis of the data. We're talking about data from 50,000 mice, 30,000 rats, 25,000 dogs. Ultimately, this entire archive came to my laboratory at Northwestern. It is in the university, and the university has supported it since termination of the DOE low-dose program. What was the result of the termination of the DOE low-dose program? I'm going to just go into the specifics here. For the U.S. radiation community, the loss of DOE low-dose program has devastating effects. First of all, the radiation community for low-dose has been decimated. Low-dose radiation biologists participate in recommendations for radiation protection, for designing approaches to deal with radiation accidents, for dealing with population exposures. In the U.S. today, these committees are occupied predominantly by retired scientists. We are not able to train the next generation of radiation protection scientists in the U.S. and will be dependent on foreign support. Secondly, NASA has a need for low-dose work with radiation types unique to space exposure. Complementary work must be done with Earth-type radiation exposures. NASA reported to the NASA Space Radiation Discipline Working Group, which I chaired, that they were looking for collaborators in Europe to facilitate their work. In the past, DOE was their partner. We have lost much of the infrastructure to do low-dose work in the U.S. Many facilities are antiquated and have not been updated in 10 years. Some have even been decommissioned. In many cases, the capacity to perform this type of research would take time to rebuild. Finally, the U.S. is currently under low-dose exposure effects data from science done in Europe, China, and Japan to support our regulatory policies. This is of concern because, one, other countries often have agendas in their research programs that are not consistent with our agendas. This is not to say that the research results are not correct, merely that the research design is set up to examine particular questions that may not be of equal priority in the U.S. Second, we do not have the capacity to reproduce any of those findings in the U.S. And finally, in effect, we are permitting other countries to set the radiation agenda for the world. Thank you.
Thank you, Doctor. Dr. Brink, you're recognized for 5 minutes.
Chairman Weber, Ranking Member Pro
Turn your mic on, please, sir.
Chairman Weber, Ranking Member Pro Tem Foster, and distinguished members of the subcommittee. I want to thank you for holding this hearing today and for the opportunity to testify on this important topic. I am Dr. James Brink, Radiologist-in-Chief at Massachusetts General Hospital and the Juan M. Taveras Professor of Radiology at Harvard Medical School. I serve as Vice Chair of the National Academy's Nuclear and Radiation Studies Board and as Scientific Vice President for Radiation Protection in Medicine for the National Council on Radiation Protection and Measurement. I am testifying today on behalf of the American College of Radiology as the current chair of its Board of Chancellors. The American College of Radiology represents more than 36,000 radiologists, radiation oncologists, interventional radiologists, medical physicists, and nuclear medicine physicians whose patients benefit from diagnostic and therapeutic uses of radiation in medicine. Without doubt, the use of ionizing radiation to diagnose and treat disease has revolutionized the practice of medicine. Millions of patients every year benefit from the use of radiation in diagnostic imaging, image-guided procedures, radiation therapies, and other applications. The effects of high-level radiation exposure on the human body, including the link between high-dose radiation and cancer, are relatively well understood. Much of our knowledge is based on decades of atomic bomb survivor data and the experiences of first responders to the Chernobyl disaster. Exposures to high doses of radiation have been associated with several types of cancer. There is much greater uncertainty as to the link between cancer and exposure to low-dose radiation. While exposure to lower doses may damage or alter a cell's genetic code, such exposure does not necessarily result in negative health consequences. This is because of the body's innate ability to repair itself and recover from cellular damage. This response is akin to your car's windshield wipers in the rain. In mild and moderate rainfall, your wipers keep everything relatively clear. In heavy and severe rainfall, your wipers can be overwhelmed and your vision blurred. The National Academy's Board on Radiation Effects Research has played an integral role in the study of the biologic effects of ionizing radiation over the last several decades, having published a series of reports on this topic. These are frequently cited in the professional literature and in regulatory and policymaking documents. However, the most recent report was issued in 2006, and an update is needed to critically explore the latest research and provide a balanced perspective on its significance. As medical providers who use ionizing radiation in the diagnosis and treatment of disease, we value the role the National Academies has played in distilling volumes of research related to ionizing radiation. To that end, the American College of Radiology endorsed the Low-Dose Radiation Research Act of 2015 in the last Congress. As this subcommittee knows, the legislation would have required the Director of the Department of Energy Office of Science to carry out a research program to enhance our scientific understanding and reduce uncertainties related to the health effects of low-dose radiation. Further, it would have required the Director to enter into an agreement with the National Academies to conduct a study assessing the current status and development of a long-term strategy for low-dose radiation research. We believe it is important for the National Academies to periodically assess the status and inform the development of a long-term strategy for low-dose radiation research. We also believe the Department of Energy and other federal agencies must be adequately funded to support low-dose radiation research activities. Accordingly, we urge that similar legislation be introduced and passed in the current Congress. This is so important because it is very likely that someone you know will undergo a medical procedure that uses low-dose radiation, and this research is necessary to better inform the potential risks of those procedures. We at the American College of Radiology and in the radiology community hope to continue to be a resource to this subcommittee moving forward. Thank you again for the opportunity to testify today and for holding this hearing on such an important topic.
Thank you, Doctor. I now recognize myself for questions for 5 minutes. Mr. Neumann, your report found that federal funding for low-dose radiation research in the U.S. had declined by almost 50% from 2012 to 2016. Now, some of the other testimony was about we had to depend on foreign research, as you heard from, I think, from Dr. Woloschak, or was it Dr. Brink? What impact has that decrease in funding, in your opinion, had on the U.S. leadership in this area of research?
Well, certainly when talking to all the agencies that are involved in this type of research, they all agreed that there is a need to coordinate and better collaborate to identify and develop the research priorities to see that they're met. And so without this leadership, there's a potential of some of these gaps not being filled.
Let me follow up on that. A couple of the testimonies said that there's no collaborative mechanism. And so, Dr. Woloschak, I'll jump over to you real quick. What does a collaborative mechanism to you look like?
So in the days of the DOE low-dose program, what they would do is, if there was an interest from, say, DOE and NASA, NASA would help fund the same project. They would give a bit of the funding and expect that they could take advantage of the data that resulted from it. That, I think, was a very good collaborative arrangement between two different agencies working together that had similar goals. That's no longer possible. NASA's working alone. They don't have that sort of collaborative arrangement. I think similar arrangements between NIH and DOE actually existed for a period of time, too. So I think those are the kinds of things that are very, very helpful.
Do you agree with that, Dr. Brink?
I do indeed.
Okay, now Dr. Woloschak makes a very interesting point in her testimony that we don't have the next generation, for whatever the term is, of scientists. We're not getting them trained since you have a college nexus there. Why is that, do you think?
You know, it's an interesting question. We have noticed that there's been a relative decline in what we call radiation professionals over the years, and it's certainly been a concern of the National Council for Radiation Protection and others. And it's not exactly obvious why there has been a decline, but we've certainly made efforts to try and rebolster and reinvigorate interest in this field, really for the sake of the nation going forward.
Are you in possession of the numbers? Do you know what that looks like? Did we have 1,000 scientists that have now gone down to 100 or 50, or do you know what the...
I don't, but we'd be happy to find some numbers for you and get those to you.
Well, I'm just curious because that's interesting why we're declining, and to your comments that we had to depend on foreign countries whose interests may not exactly align with ours.
Yeah, I can comment on that as well. I mean, I know American Society for Therapeutic Radiation Oncology did a joint meeting at NIH about 2 or 3 years ago to try to talk about the decline. And I believe what the major result of that meeting was to say it's declining because we don't have people funded in low-dose radiation research. So then to take students into the lab to do research and learn how to understand low doses, there were no training grounds.
So let me paraphrase that if I understand. If we were to take and we were to have a more better funded program, a more collaborative approach where we've focused on this, then we could perhaps induce students to be interested. Is that what you're saying?
Oh, absolutely. I see it with my own students, actually.
Okay, I'm going to change gears a little bit. You said in your testimony that there's a lot of naturally occurring low-dose radiation. You went through some examples. Do we have any facts and figures? This may be for the both of you doctors. Do we have any facts and figures on what percentage of that occurs due to medical exams? I mean, is it 5% in the general population? Is it 3%? What percentage actually occurs due to medical exams?
We actually wouldn't call medical exams part of natural background. So,
Well, I don't mean natural, but natural was one. You know, you go through airports, you go through screening.
so medical exposures make up the highest percentage of human-made exposures that we have in the U.S.
What
today.
percentage is that?
I think it's about 45%.
45%, okay. And it's even in the water you drink before you take another drink. I wanted to be sure you remember that. Okay, another question. Dr. Woloschak, in your testimony, you said you had considered that there were also risks to the unborn. Is that through the mother or is it through the medical exams? Is that, how do you consider that?
Actually, the data out of the EU right now is suggesting that there are effects during pregnancy that are probably coming through the mother in some way, and we don't actually know the low-dose mechanisms, but it looks as though the unborn may be more sensitive. And even the data coming out of Hiroshima and Nagasaki RERF studies suggests that the very young are more susceptible to cancer induction than very old from cleanup sites, from those sorts of things.
All right, well, thank you for that reminder. Two quick questions. I'm a little over my time. Nagasaki, Hiroshima, and that Japanese-related event, that population has to be going away because those survivors have to be diminishing almost daily. Do you know how many of those are left?
I don't know the exact numbers, but you were exactly right. They are declining significantly. I was just there maybe 6 months or 8 months ago, and they're continuing to study the population as long as they can. But one thing to realize is most of that population got sort of higher dose, what we would consider to be low, moderate dose, not the very low doses that we would get say, from occupational exposures
All
here.
right, and then finally, I think it was you, Dr. Brink, who talked about Chernobyl. Do I remember right?
Yes.
And so let's jump over to that population. When was that event, and how many were affected? Do you know that offhand?
I don't know that off the top of my head. I'm
Yeah.
sorry.
So it's a more recent study.
The event was about 30 years ago. The problem with the Chernobyl studies is that the dosimetry is a little bit off. There's a lot of work being done with the dosimetry,
Right.
but it's hard to analyze easily.
Okay, well, thank you. I'm over my time, so I appreciate y'all, and I now recognize Mr. Foster.
Thank you, Mr. Chairman. I'm trying to puzzle out why it's been difficult to sustain an interagency collaboration on this. There's a bad reason this could happen, which is that bureaucracies under financial stress will often try to get rid of programs, shared programs that they don't view as along their core line of business, and it's a natural thing. I think the only solution to that is to have the Congress say, "Hey, this is something important that's slipping through the cracks between our agencies," and basically knock heads to make sure that those are maintained. There's another potential technical reason. Are there real differences in the types of radiation exposures that are of interest to different agencies? If you're worried about health care, it's probably different than if you're worried about space-based exposure versus ingestion of radioisotopes from nuclear accidents and so on. And so how much of that difficulty has to do with when you sit down to write the specifications of what you want to learn, that you find different agencies have different specifications? Does anyone want to?
Yeah, you're exactly right, and in that different agencies do have different needs, but a lot of times they overlap. So for instance, while NASA is going to care about space radiation, and DOE is going to care about Earth-based types of radiation, you actually almost always need to use the Earth-based radiation as a control to understand space radiation. So they should actually be cooperating. They did for years. You asked the question why they stopped, and I have absolutely no clue. Probably you're right. Having somebody from DOE at the table would have been useful.
Yeah. Any other comments on sort of the technical differences between the types of exposures?
Well, I think just talking to the range of agencies that we met with, they all agreed that there were some common areas of research that would be of use to each of the agencies. So that's why they would sometimes jointly fund some of these ongoing studies, like the million-person studies and other studies, where they can get research that would be useful to their particular settings.
I agree with Gayle that there's a fair amount of overlap too, which makes it a little bit puzzling, but certainly there's obvious distinctions, NASA being very interested in cosmic radiation and so forth, but otherwise there's a fair amount of overlap in just how we address these.
Okay. Now, the other sort of big question here is, let's say that you're able to go to a less conservative, zero intercept model for what you thought the human danger was. Is there anyone who's done, an exhaustive and high-quality study of what the health and economic impact of that would be? Just assume that we declare a higher level of, a de minimis exposure to be actually safe. What would be the economic impact? What would be the indirect health impact in terms of more allowable chest X-rays, more, a shift in our energy mix, presumably towards nuclear, and so on?
It's an interesting question. I'm not aware of any such analyses, but certainly as practicing physicians, most practicing physicians are still very much recognizing that the benefits typically outweigh the risks. And so I don't know that there's been a huge reduction in the use of medical imaging, for example, because of whether there's the linear north threshold intercepting the origin of the axis, or whether they're considering there's a threshold effect or even a hormetic effect. Most physicians are still focusing on the benefits and practicing appropriately.
But there's still some limit. I mean, they reach a point at which, you've already had, 5 X-rays this month, and maybe we shouldn't have another one. And what is there a sound scientific basis for that kind of decision?
In my opinion, no, there's not. And when I'm faced with patients who are worried about those kind of thresholds, I'm going right back to the benefits and saying, what is the reason why your physician needs these studies? Because the benefits are clear-cut. The risks are very much uncertain, and typically, in almost all cases, when there's a real sound medical reason to do the study, we're going to favor doing the study over a theoretical risk.
But it's your suspicion that, to the extent that doctors are limiting, things like X-ray or PET scans or so on, that it's probably the conservatism, in related to radiation doses probably nets out harmful for patients?
Well, we certainly will favor imaging tests that don't use ionizing radiation when we can. So, for example, MRI or ultrasound don't have the same risks, and we certainly, and when we do need to use ionizing radiation, we're promoting using as low as reasonably achievable doses. But in terms of an economic threshold or economic benefit to a threshold, I'm just not familiar with any of those studies.
Yeah, but where I would say where the economic threshold would probably come in, and I don't actually know the numbers, would be in how far do we have to clean up our nuclear waste sites. It's probably a difference of trillions, at least billions of dollars, if we accept the linear non-threshold or if we have a lower threshold for cleanup. That's where I would think that there'd be a big savings in money.
Yeah, I know. I recall a paper by Richard Wilson of Harvard Physics Department, who you may know is, who was actually, I believe, one of the first Westerners allowed at Chernobyl and a real expert on this. He calculated the optimal radius of evacuation from Fukushima. Because you can mess up either way. If there are two effects, obviously. People suffer from exposure to radiation if they're too close. On the other hand, there's a well-documented probability of having people die, particularly the elderly, if you move them, just relocate them. And so this allows you to calculate an optimal radius of evacuation. It was the conclusion of his paper, at least, that actually the Japanese evacuated too large a radius. And ultimately had a negative health effect from that decision. And so this is just another example where getting the science right here is so important. And now I'm over time myself, and so happy to hold back.
Okay, thank you. And I now recognize the gentleman from Oklahoma.
Thank you, Mr. Chairman. Dr. Woloschak, one of the tendencies, whether it's in Congress or in the executive branch, or for that matter anywhere out in the real world, is sometimes if we don't want the answer, we don't ask the question. So from that, guys, let me quiz you, ask you for your opinion. The way that this research was determined to no longer be conducted, is that an example perhaps of someone not wanting the answers that would come from it? And if I look at this in the overall context, I mean, we've discussed health issues, we've discussed terrorism issues, we've discussed the space program. From the perspective of my constituents back in Oklahoma, it seems that not knowing this information or taking the research to its ultimate conclusion puts us in a position to make perhaps decisions based on inaccurate facts. Could you expand on that a moment? I mean, from the perspective, say, of NASA, if we're going to the moon, if we're going to Mars, we need to know these things, correct?
Yes, in fact, when I ask astronauts, they say exactly that they care about the risk for cancer. They don't care as much about the risk of blowing up on the launch pad, which puzzles me. But
Launch pad is instantaneous, cancer can take a long time.
That's what they say. That's what they say.
I appreciate their point.
But I think you're exactly right. The thing is, I can't actually speculate for why people don't want to know the answers to these questions or why it's been sort of stopped. But I will say it's been a pattern, at least from my experience within DOE, because we had a very large-scale program. I believe it was one of the best in the world for with these animals. They just terminated it, spontaneously. Then they started up the low-dose program, and then again, they terminated it very, very rapidly. I don't know what the reason for that. It could just be something sporadic. Again, probably somebody from DOE could answer that better than I could.
One of our responsibilities in Congress, and most assuredly in our oversight capacities, is to assess these situations and compel the right actions to take place to help provide guidance to the executive branch. I always remind my constituents in town meetings, no matter what anyone says at the other end of Pennsylvania Avenue, we write the laws. No matter what anyone says, the responsibility is for those laws to be implemented accurately and efficiently. So I find this a very concerning issue to me in a variety of ways. We have debated on this committee, as the chairman knows, and in Congress for years about how to store waste, whether a facility underneath a giant mountain in the west should be used, or it's better to store things down the street from me that I may not know about because that's where it was created, or where we go ultimately with NASA. Well, I appreciate your observations and the willingness to try and preserve as much of this research as could be done. Do any of your colleagues on the panel wish to address that question about what the background might or might not be that led to the decisions that have brought us to this point?
Well, let me add that the best answer we could get from DOE was that they had other research priorities in bioenergy and environmental research that they wanted to fund. What was curious to us is that in 2016, the advisory committee report identified a number of areas that DOE thought would be useful to reduce the risk of cancer, to understand better the low-dose risk. And it also supported convening workshops between agencies to collaborate on a research agenda. But then the report ultimately concluded not to continue the research. So we couldn't get a better answer than that, that it's just there were other research priorities.
I have nothing to add to this one.
I think perhaps I've made my point, and I appreciate that, and I'll yield back the remainder of my time, Mr. Chairman.
Which is, by the way, why we need a single collaborative mechanism to make that decision. And I recognize the gentleman from New York, Mr. Tonka.
Thank you, Mr. Chair, and thank you to our witnesses for joining us today. I am happy to see the committee actively engaging on what I believe is a bipartisan issue where scientific research has an important role to play. Basic research on low-dose radiation is of vital importance with far-reaching consequences for human health, future technology, certainly for human exploration, and national security. So there's still a great deal in this field we do not fully understand. And I heard, I believe, from just about all of you that we need more attention to the research piece. Is that in agreement across the board, that more research commitment is required? Mr. Neumann, I think you're, I see two heads nodding yes. And
Yes, well, I would just say yes, that we identified, from the agencies identified for us, the research priorities, that there was obviously a number of areas that still had a great deal of uncertainty, and they believed there would be benefits to continuing that research.
Okay. Now, let's get into the GAO report. Mr. Neumann, the primary recommendation in the report is that DOE lead the, and I quote, development of a mechanism for interagency collaboration on research on low-dose radiation's health effects. Now, DOE disagreed with your recommendation, saying that it would not be appropriate for the department to lead such an interagency initiative. Do you think it would be inappropriate for DOE to lead this interagency effort?
Not at all. In fact, we thought they were in the best position to lead this effort, given their past leadership as well as their responsibilities under the Atomic Energy Act. And it's also consistent with GAO best practices that we've identified for interagency collaboration, that if you don't have someone leading such a mechanism, it's difficult for agencies across the government to coordinate and make more effective decisions.
Is there a particular precedent you would point to for DOE to take on this role?
Well, I think Dr. Woloschak also pointed out in one of her responses that DOE did do that in the past, and I think that's what we also saw.
And your testimony mentions that GAO's previous work has shown that collaborative mechanisms can serve multiple purposes to develop sound science and technology policies. Can you further elaborate on the specific projects that GAO has examined to support this conclusion?
Well, I can get back to you with specific examples, but there's been a range of examples in the past where in various settings where there are multiple agencies involved in research areas that by having a collaborative mechanism, they can be more effective in achieving those goals. And without that leadership, those efforts are likely to not be as successful.
And DOE has already responded that they do not concur with GAO's recommendation. So are there alternative options that GAO consider or should consider or have considered when examining this issue that this committee should be aware of?
Well, I think we did consider whether or not other agencies would be in a position, but we came to the conclusion based on the evidence that DOE was in that best position. Obviously, additional direction from Congress might also encourage them to take a leadership role.
And in the event that DOE does not implement your recommendation, are there other coordinating bodies or mechanisms outside of DOE, such as OSTP, that could potentially fill this void?
In some of our other work, looking at OSTP, they usually are not in the position to direct agencies in some of these science efforts. They bring agencies together, but then rely on the agencies to determine amongst themselves how to lead various efforts. So I would say that I think having an agency lead would be very effective.
Thank you. And Dr. Woloschak and Dr. Brink, most of the conversation in this field is about the detrimental effects of radiation exposure. Some researchers have indicated that there may be positive benefits from exposure to low doses of radiation, but there's still much more that we need to learn. So my question is, what is your perspective on the possibility that there could be positive health effects as a result of exposure to low dose of radiation, and what could some of these positive effects be? Dr. Woloschak?
Yeah, so we for sure know that low doses of radiation boost the immune response, can actually add to health of people. The problem is, how do you balance that with potential risks of cancer and other effects? So the risk of cancer is something that's very questionable at low doses, but there certainly are many studies that have shown that low doses also do boost an immune response. So it's that balance that I think is going to be hard to understand.
Okay, thank you. And Dr. Brink?
Well, so the idea that radiation could actually be somewhat beneficial at low doses is called the hormetic effect, and it's yet another step beyond where we are today, which is just accepting that there might be a threshold rather than the no threshold hypothesis. So I tend to, as I alluded to in my windshield wiper analogy, that I tend to think that naturally occurring processes in many examples in nature do have nonlinear responses, whether they be that one or many others we could think of. And so, to my way of thinking, just getting to the point of acknowledging or understanding if there's a threshold through additional research that might show that would be the first step before even getting to the hormetic effect.
I thank you all very much. And with that, Mr. Chair, I yield back.
Thank the gentleman. The gentleman from Illinois is recognized for 5 minutes.
Thank you, Chairman. Thank you all for being here. Appreciate your work and appreciate your testimony today. Last Congress, the House unanimously passed legislation that I had sponsored. It was H.R. 35 to authorize a low-dose radiation program. was also glad this was included in the committee's unanimously passed Energy Research and Innovation Act earlier this January. Hopefully, we can see that get over the finish line in the Senate, like a lot of other things too. But coming from a state where more than half of our energy comes from zero-emission nuclear energy, the safe handling and storage of nuclear material is vital. University of Chicago will be also celebrating the 75th anniversary of Chicago Pile 1 next month, so we've got the longest record of work in this space. Regulations based on science are necessary so that we're doing what's needed while not overburdening our research facilities and clean energy industry. Dr. Woloschak, if I could address my first question to you. In your prepared testimony, you discussed new technologies that can be applied to this research. What are some of these new technologies, and in your opinion, how promising are these potential applications?
Yeah, so the acting Mr. Foster had mentioned that there are large-scale data analyses that are quite possible, and we actually are trying to take advantage of that now, looking at data sets from the U.S., combining them with data sets from the EU, in fact, so we can look at 150,000 mice, being able to look at 31,000 dogs. That sort of data on a large-scale analysis was not even possible years ago. So statistical analyses have changed, computational approaches have changed. That's one thing that's going to make a very big change. The second thing is that, as was noted before, we can do single-cell sequencing of cells. So I think that technology is going to be extremely important. We can also make new kinds of mice that we couldn't make before. So if we wanted to try to create an animal with particular types of genetic susceptibilities, we can look at those with a far fewer number of animals. So there are a lot of new technologies that didn't exist when this program was even terminated 5 or 6 years ago. I mean, science is moving really fast.
Right. Dr. Brink, in March of 2013, Dr. Paul Cabot from Harvard Medical School co-signed a letter to the former science advisor, Dr. Holdren, detailing the gaps in knowledge on low-dose radiation and the continuing need for this research. Do you know what response he received on that?
I'm sorry, I do not, but we'd be happy to investigate and get back to you about that.
That'd be great if you would. Back to Dr. Woloschak, if I could, you testified that you have accumulated the archive of referenced animal tissue samples from DOE's closed low-dose programs in your lab at Northwestern. What so far have you been able to determine? You kind of referenced that, but what else are you seeing? How do you plan to curate the data to make it publicly accessible to? And if DOE does restart the program, will that also make it so that your data, it'll be easier for you to make that public as well?
Yeah, so these data are amazing. I mean, these were who does a 50,000 mouse experiment anymore? I mean, we don't have the capacity to do that. 21,000 dogs? I mean, so rather than throw it out, we actually took the data sets, and because of DOE's the support through the low-dose program, we were able to put much of that data up on a publicly available website now. The rat data are still not up on the website. Not all the dogs are up. We're trying to make it be publicly available so anybody can study it. That has been our goal. But the problem is keeping the data without having the tissues to go back to verify is a problem, and that's why we've tried to keep the tissues as well, and I'm thankful to my university who has supported us through the hard times.
That's great. Also, Dr. Woloschak, a 21st century science workforce is something this committee has been focused on. We spent a lot of time discussing it and want to make sure that we're ensuring that we have it. In your testimony, you identified workforce issues in the field, that the majority of radiation scientists are retired and that there are not enough young scientists to replace them. How do you recommend that our nation and our world address this developing issue?
The reason why students don't want to go into radiation biology is because there's no funding. So they feel like they're going into a dead-end position. And honestly, today I can't recommend for my students to go into that field. I also work in nanotechnology, and I push them in that direction because there's funding there. I believe that more funding for the field would really enhance capabilities to generate a workforce.
That's great. In my last few seconds here, again, Dr. Woloschak, the National Council on Radiation Protection has been writing a commentary on recent research's implications for the linear no-threshold model of radiation protection and expects to put a report out soon. Based on your review, what have been some of the major recent studies in radiobiology over the last 5 years, and what impact, if any, are they likely to have on the current linear no-threshold model?
Right, so the report's not out. I'm actually on the board for the NCRP, and the report's not quite out, so I'm not at liberty to say what they're going to say, but certainly there have been, I believe they're going to still they're using the human data as their primary mode for saying LNT is still the safest with today's current data. They will say that more data would be useful.
Okay. Well, thanks again. Thank you all for being here. I yield back.
I thank the gentleman from Florida is recognized for 5 minutes.
Thank you very much, Mr. Chairman, and I want to thank our panelists, too. I was fortunate to capture them on the way into the room and had a chance to talk to them earlier, and I'm grateful for that. I appreciate the work that you do. And also, Mr. Neumann, we didn't get a chance to talk, but I welcome you because I understand that you are the one person in the room who's most able to direct the Department of Energy to restart this research, and that's exactly what we would like to see you do. I think you've gathered that from all of us. Congressman Foster suggested that we adopt a standard that has been called, I think Dr. Brink said it as low as reasonably achievable radiation, and I think that is a great model for us to be thinking about. I can tell you as a practicing surgeon that we had a lot of pressure on us to limit radiation exposure, even at the risk of being ignorant of the patient's underlying pathology. So this work is very, very important. My question, and this will be part to Dr. Woloschak on the therapeutic side, but part to Dr. Brink on the diagnostic side. So have we gone overboard in stressing the risks associated with the proper use of diagnostic radiation and therapeutic radiation?
Maybe I can jump in first. I do think that, as you probably experienced in practice, that sometimes patients, there's been quite a lot of press that patients will be exposed to about the potential risk, and sometimes they'll confound potential versus actual, and will provide a lot of concern about even getting the necessary imaging that they need. And so very commonly, I'll work hard to try and convince a patient that the benefit of what they would see from undergoing the test would greatly exceed the potential risk that they might face. And I imagine you've faced that in your practice as well.
It was just very, very commonly, and I think there's a sense of alarmism actually among the patients, and they're getting this information from whatever sources that we're over-radiating them dangerously. And you're looking at somebody who might have something as simple as a kidney stone, but if they're obstructed and they're infected behind the obstruction, that's a potentially fatal problem. Dr. Woloschak.
Yeah, I think for therapeutic radiation oncology, where you're treating patients with cancer, most often they don't really worry about what the risks are going to be, but where it comes to play is because you're giving a dose all over the body, secondary cancers can come about as a result of the radiation exposure. So after they've been treated, then they're worrying either about, am I going to have a recurrence, or am I going to have a secondary cancer? So it becomes an issue after the fact. I don't think it influences therapy, but certainly the one thing that does influence therapy is how can we make that treatment location be as small as possible to minimize dose to the rest of the body. So we do actually understand quite a bit about low doses because of the scatter of the radiation when we give therapeutic doses.
So that's actually an interesting subject for us. I mean, we obviously worried about bladder and rectal cancers following prostate
Absolutely.
radiation. And can you give us a sense of how common that is,
Yeah, I mean,
rectal and bladder?
Yeah, I'm not really a radiation oncologist. I'm a radiobiologist that teaches radiation oncologists. But the worry is that there is a considerable risk, and in fact, that's what's affected the way that we deliver. So as you know, we're now using seed therapies, for instance, because of worries about radiation damage to the bladder and rectum, mostly from late tissue toxicities that might result. Secondary cancers, there are quite a few studies that have been done looking at what percentage that you'll find in the field and then outside of the field. And there is a pretty considerable risk, not as much to the rectum, but to the other abdominal areas associated with particularly prostate cancer.
And finally, if I could, and one of the confusions is when we're talking about radiation, doses of radiation, we think we're measuring it in some one type of measurement. And I'd like you to address a little bit either what measure we should be using or how confusing that subject is.
Right, it's a great question. There's so many things that need to be investigated in research on low-dose radiation, and not the least of which is just how to measure it. There's much literature that reports the measurement to the entire body, the organism, the effective dose. and others that really focus on the specific organ that's irradiated. And this alone actually creates a great deal of confusion, and someone just owing to the uncertainty of the best way to measure the dose from any particular study or therapy.
Any follow-up on that?
Yeah, and I would agree with that, and also add in that it's a big issue for discussion. I mean, like the National Council on Radiation Protection, we talk about what's the best way to try to calculate dose and figure out dose. It's controversial, and believe me, you could fill a room talking about it for days.
So my time has run out, but I hope, Mr. Neumann, what you take away from all this is that we all are cheering for you to go, get on this horse and ride it home. Thanks so much. I yield back, Mr. Chairman.
I thank the gentleman. Mr. Foster, you recognize.
If I could, just a point of clarification. In my remarks, I did not specifically advocate for ALARA as low as reasonably achievable, which is, the rule under which I worked for many years at a national lab. I view ALARA as largely an expression of our ignorance. It's what you do when you say, since I do not know whether or not this may be dangerous, in the absence of better numbers, let us do as much as reasonably achievable, whatever that means, to minimize dose. And so it's an example of a real cost of not having the real numbers on this.
Well, I think you said it's a result of ignorance. Doesn't that apply to a lot of what Congress does? I'm just asking.
Well, it's also true that we work in the U.S. Capitol, which has, because of the stone that's used, has a radiation levels that would not be allowed for incorporation into a nuclear facility.
Well, see, that explains what I'm talking about. We're going to do a round two, and I don't know if the gentleman from Florida wants to hang for that, but at least Mr. Foster, are you good, Neil? Thank you. We would love to have the DOE in here as part of this discussion. We'd love to have the Undersecretary for Science from the DOE, but we're waiting on him to get confirmed. So if we can make that happen, that would be helpful. I did note in the testimony today that the Atomic Energy Act, and this is for you, Mr. Neumann, when the DOE said that they didn't think that they wanted to take that purview, the Atomic Energy Act was of 1954. Did they cite reasons from the Atomic Energy Act, or do you remember why they turned it down?
They did not cite that. We pointed that out in our response to them, that they do have these responsibilities, but they...
Well, I saw that. Of course, it is, at this point, 63 years old. So I guess the political question may be in part, do we need to revisit that act? Do we need to clarify what their role might be in this instance?
The language is pretty plain in the Atomic Energy Act that they're responsible to lead, radiation research, given their
Which
mission.
would include low dose.
Right, which would include a range of, so, you can always have more specificity, but the language is pretty plain.
Yeah, okay. Dr. Woloschak, you said that low-dose radiation could boost the immune response.
There are certainly some studies that have demonstrated that in the literature, and it looks to be that that's true.
Okay.
The problem is it may also cause cancer, and so do you want to tell somebody to go sit in a radioactive spa and enjoy it and
Right.
get a boost to your immune system if at the same time they're at risk for cancer? And it's those unknowns that make it be so difficult for what to do with low-dose radiation.
Right, and is that probably true? One of the difficult parts of this in that research is because everybody's DNA and makeup is different. How do you decide, how everybody's going to be affected by that? Is there a time in a person's life, generally speaking, in an age, I think some of the testimony, I don't remember if you or Dr. Brink said cells repair themselves. I think it was yours.
Oh, cells always repair themselves.
Right.
So the question is, how much can they repair?
But if they repair themselves inappropriately, I forget the terminology, then there's I guess they mutate and they create a problem in that regard. Is there an age? I mean, do you find that when the person gets older, midlife? Is it 50? Is it 30 years old, 50 years old, 80 years old, or no? Do you have that research?
There's a lot of work that says that as people get older, their repair capacity decreases.
Well, I know that's true.
Yes, so we all know that. But the other thing is that in general, the young are more susceptible for cancer induction than the old because they're going to live longer.
Okay. And then, Dr. Brink, you brought up a new term for me. You said the idea of the beneficial low dose is called the hormetic effect.
Yes,
Spell that.
HORMETIC.
Okay. Would you elaborate on that, please?
It's a theory that I think was being alluded to earlier, which is that that low-dose radiation could in fact be beneficial, either through stimulating the immune system or what have you, and it's very much a theory at this point.
So how did it come about? How long has it been around?
I'm not sure I can answer specifically. It's not new. The theory's been around for some time.
Where does the name hormetic come from?
Hormesis is the root term, and I'm sorry, I'm not a linguist. I'm not sure I could answer that better.
Okay, you just said that's the term that was applied.
Yeah.
In Texas, in Andrews County, out by El Paso, or actually I think it's maybe further north toward the Panhandle, is a company called Waste Control Specialists, and they take on low-level radiation waste. Are any of y'all aware of that facility or familiar with that facility? So when we're talking about, you know, doing research on low-level waste, were any of the low-level radiation waste facilities included in that research? Do you know?
Not aware.
I'm not aware of any.
So when we talk about doing research on low-level radiation, and maybe this is for you, Mr. Neumann, why wouldn't it be that the DOE or anybody that was involved prior to 2012 when the funding was starting to be diminished, why wouldn't they have included those facilities? Any idea?
The research they've been conducting has been either epidemiological, you know, where they're looking at a population of people over time, or radiobiological, which involves, you know, lab work that Dr. Woloschak talked about.
Right.
That's the type. That's how they were determining the potential effects of low-dose radiation.
One approach would be to go to a site like the one you've mentioned
Right.
and look at what the doses are, get a good dosimetry, and then do some lab experiments to try to answer what those effects might be, in addition to studying the population.
Dr. Brink, I think you were going to say something.
There certainly have been other efforts to look at radiation workers for their risks, and a more recent one is the Million Worker Study, looking at 1 million workers in the nuclear power industry that's
Right.
underway.
Well, and that was the reason I asked, because those are typically associated with high-level radiation, right?
Well,
or
hopefully
the
hopefully not for the workers.
Well, I mean, you're hoping not, but I mean, you go in there and you think, well, those would not be considered low-dose radiation levels, right?
The Million Worker Study is really about low-dose workers, people
At
that were
nuclear-
exposed at low-dose.
At nuclear plants.
Yes.
I would think the propensity would be to be concerned, well, I guess any level, what would you call it, the lowest risk assessment level? But it's interesting to me that you only talk about nuclear energy plants, for example. You don't talk about the waste facilities. Perhaps that's something that should be included. So I appreciate that. I'm going to yield to the gentleman from California.
Let me apologize that, of course, as usual, we're scheduled with 2 important hearings at exactly the same time, and I will review your testimony later on. But so if I ask a question or two that is repetitive, excuse me for that. Let me just, people are going to the dentist, and you're taking your pictures, or you go to a doctor and they're taking x-rays of you. Is this the type of low-dose radiation that deserves more research?
So when we talk about low-dose radiation, those kind of doses are extremely low, and more commonly, and they're 2 or 3 orders of magnitude lower than the doses that even we call low dose that we're focused on mostly from a computed tomography or nuclear medicine procedures.
So we don't. So one thing coming out of this hearing today is that you're not suggesting that this is a potential danger that needs further investigation in terms of the type of radiation that we are exposed to in the health industry, like medical health.
Right, well, the topic is very much about doses dental in the health industry. You were speaking more specifically, I think, about dental X-rays or
Right.
extremity X-rays, which are extremely low dose. But more commonly, the doses from a imaging procedure, such as a CT scan or a nuclear medicine test, would be also low dose, but at a magnitude that we're we're really speaking about what would be where research would be helpful to understand better what the potential risks might be. Because at the moment, we only extrapolate from high dose exposures to kind of guesstimate what the risk would be at those kind of doses.
And what about, is this idea that power lines, I guess power lines wouldn't be, I remember there were some complaints in the past that power lines posed some sort of health threat. Was that due to radiation or something else?
You know, I was on a committee that investigated the effects of electromagnetic power lines, and that kind of radiation, or the quality of radiation, is different than the ionizing radiation that we're talking about now. Now, in fact, most of those studies said that there were no effects from living by the high power lines, but this is a different type of radiation.
All right. What about that?
And it's also a different kind of radiation than the cell phones have as well.
Okay, so you aren't today testifying that a warning to all of us to put this on the speaker rather than next to your ear, or that we better watch out when you go to the dentist, or if you have to get something x-rayed so the dentist or so the doctor can figure out how to help you, we don't have to worry about those things?
So I think what we're trying to say is that the cell phone, that quality of radiation, is something that we're not concerned about here. What we're concerned about is ionizing radiation, and ionizing radiation is dangerous because it breaks bonds, and that's why we're
Give me some
worried about it.
example of ionized.
So the dental X-ray is a type of ionizing radiation.
Okay.
The other types would be the CT scan, the chest X-ray, what we find in nuclear power plants, what we use for our nuclear power. All of those would be examples of ionizing radiation. They're a type of radiation that causes the breaking, has the potential to break our bonds in our genetic material.
Okay, so is it a fundamentally different type of radiation that we're talking about? I mean, this is...
It is fundamentally different than the cell phone or the power line. Okay. Fundamentally different.
Okay, so we're not just talking about dosage, we're talking about an actual difference in the type of thing that we're looking at.
Right, between the cell phone and the power line and the dental X-ray and chest X-ray and the nuclear power plant, there's a difference. There's not a difference between the dental X-ray, the chest X-ray, the CT scan, and the nuclear power plant. Fundamentally, those are all ionizing radiation, and they're all capable of breaking bonds, which is why there's concern about whether they're dangerous or not. Mm-hmm. As Dr. Brink just mentioned, the dental X-ray is so very, very low. Most studies suggest that, in fact, that's not something that we need to be concerned about, although there are people who will be. But that when we start to get up into like many CT scans, when we start to get up into nuclear power plants, those are things where we might need to think a little bit more carefully about dose.
Well, we do know also, look, I'm here to learn, okay, so don't think less of me for asking stupid questions sometimes. When you go and you're treated for cancer, aren't you being dosed with radiation? And if radiation causes cancer, what are we doing?
So that becomes one of the biggest questions in treatment of patients with cancer. You're absolutely right. The dose we're giving to the cancer to kill it is very, very high. But what happens is high doses kill cells. They don't cause cancer, they kill cells. What causes cancer are lower doses where the cell still lives, but it's picked up mutations. So when you treat somebody with cancer, you give this whopping dose, it kills the cells, they're gone. But around that dose, there's often a lower dose. And then there's the risk of a secondary cancer, a second cancer popping up. But the problem is the person's life is at stake, so you just go in and you treat the cancer because you've got to save the life then, and then you worry about the effects later. But it is a risk. It is a risk.
All right. Well, thank you very much for drawing our attention to this issue. Thank you, Mr. Chairman.
Thank you, and I apologize to Mr. Foster. I should have recognized him next. Bill, you're up.
All right, thank you. let's see, first, I just want to comment on this beneficial effects of radiation. You know, this has been speculated upon, I guess, as long as radiation was known. My mother, when she was growing up, I guess people thought it was a good idea to treat acne with very large doses of x-rays, for which my mother enjoyed having various forms of skin cancer towards the later years of her life. On the other hand, you know, my brother, who has stage 4 esophageal cancer, benefited tremendously from a focused dose of radiation on his tumor. And so the better scientific understanding yields better health outcomes here. And that's one of the reasons that we really want to, you know, keep doing this research. Now, in regards to the hormetic effects, you mentioned the immune system is activated in response to radiation dose. Is there also evidence that this can trigger autoimmune diseases as well? Is there a danger there as well as cancer?
Look, I want to stress that we don't understand enough about low doses to even say, yes, there's this big hormetic effect. What I can say is, in the literature, you can find reports that when you treat with low doses, you stimulate animals to have a better immune response. Is there the possibility of autoimmune disease? You're absolutely right. That is a possibility that could come with it. So just as much as it looks like there are positive effects, there may also be negative effects, and that's why we have the need to do research at that low dose range.
Okay, and similarly, DNA repair mechanisms are modulated, you know, by various factors inside biology. Are there documented effects of radiation on how active the DNA repair mechanisms are?
Certainly, we know that the repair mechanisms are sitting there kind of raring to go, and when you irradiate, they go right to the site within almost nanoseconds to begin to repair. So the repair process is extremely rapid, begins almost immediately following radiation exposure.
Yeah, and it's my understanding that there is some, you know, scientific, at least speculation, if not research, that you may be able to treat astronauts with you know, drugs, for example, that they activate the DNA repair mechanism to make them more radiation resistant. And
NASA's looking for mitigators exactly like that right now, so you're right on target.
It's sort of an infinitely complicated problem. And now, I'd like to actually stand up in favor of DOE a little bit. It was not a completely thoughtless abandonment of this. And if I could have unanimous consent to enter into the record a letter.
Without objection.
A letter to the Secretary of Energy Advisory Board dated on this subject, dated June 23, 2015, which makes two interesting observations. The first one is that, quoting from the letter, it's highly unlikely, and I would say impossible, that a group of experts would, after review and deliberation of the vast literature in this subject, come to the consensus or come to a consensus, or that consensus would resolve this issue to the satisfaction of the regulatory authorities or the public. You know, this has to do with, is there a path to success here, even if the science became clear? And I was wondering, well, I'll ask you for comments on that. The second thing I want to point out is that this same letter from the CIAB says the CIAB does not believe that DOE should abandon its research on low-level radiation effects. And so although it expressed skepticism on a path to success, both in convincing the regulators and the public that this could be a settled issue, they did also recommend this. And so the letter is, I think, good, interesting reading for anyone you know, just trying to evaluate why the DOE went the way it did. So any comments on that?
Yeah, I mean, so as a person that sits on a number of regulatory boards that discusses these and mostly makes advisory decisions, I mean, I think it is true to say that if you don't have data, then you always say, well, we can't imagine what we can get to solve a problem. So DOE is exactly correct in saying we can't imagine what it would get to solve a problem. But at the same time, what I'll say is I've seen policies change because of data. So things I never expected, like to have the limit for the dose for the lens of the eye, it's dropped because of new data and new results. It's dropped internationally.
The limit dropped in the sense of being more conservative or
being more conservative in that particular example, because cataracts were popping up at lower doses than people expected. And nobody would have imagined that happening 5 years ago. It was just not possible. So I think that it's easy for DOE to make that statement that things will never change. But the fact is, data do convince people, and that's why more data are needed.
Yeah, you know that it used to be popular to tune up electron beam lines by looking at, steering the beam into your eyeball and looking at the Cherenkov radiation. Anyway, so I just want to, in the time that I barely have here, to bring up the issue of money. I mean, the reason that ultimately this program was discontinued is this the stress that in real terms of the budgets in the Department of Energy. So I have a lot of sympathy there, and I wish this could be a uniformly bipartisan issue. I was very disappointed when the Trump administration proposed, I think, a 16% cut to the Department of Energy, and I was unable to get bipartisan support for a letter, urging against that. So this is, it is not only authorization that counts; it is appropriations, and I think that everyone paying attention to this hearing should understand to watch votes on budgets and appropriations and not just authorizations. I will thank you, Mr. Chairman. This has been a really great hearing, and yield back.
Well, I thank the gentleman. I do want to point out that we're not enamored by those cuts either in every form. There were some cuts, but not all of them, so I thank you for saying that. I do want to ask probably a more technical question, Dr. Woloschak. Ionizing radiation, you specifically said as used in dental x-rays, they break bonds. Would you explain what you mean by that?
Yeah, so ionizing radiation is defined by any radiation that can cause an electron to be ejected from an atom. That's actually the official definition. So if you think about the removal of an electron from the atom, so go back to high school
It's
chemistry.
going to change the structure.
Then that ejection process causes bonds to break. And what we care about most as a radiation biologist is damage to our DNA. So when we break bonds to DNA, then we have to have processes in our cells that repair it. And actually, we have fabulous methods in our cells to repair it. It's incredible. But that is the definition officially of what ionizing radiation is.
Okay, are there other types of radiation?
Sure. So ultraviolet radiation that we get from the sun when we get a sunburn, that's a different quality of radiation.
So that's low level.
But it's not ionizing. So so that's not what we've been worried about here, because it's not ionizing. We can protect with it with sun screens and things like that. Electromagnetic radiation that comes from power lines, that's another type of radiation. It's not ionizing. Radiation that we get from our microwave is also radiation, but it's not ionizing.
Okay, I've often wondered about that, the microwave analogy. How many other types of radiation would you say? Are there 6?
So yeah, they're probably about, so from the electromagnetic spectrum, we go from extremely low frequency radiation from the power lines, we go to radiation from infrared. I mean, so there's a spectrum of probably like 7 or 8 types, and it depends on how you divide it.
Okay. All right, that's actually probably, unless you have any other questions.
No, maybe if I could have just one.
You betcha.
Final comment. This is a reminder of how great it is to have the GAO around. Having an organization that provides high-quality, nonpartisan analysis is indispensable. We've, for good or ill, we've taken the sides of congressional staffs down to dangerously low levels, and that actually causes us to depend on organizations like yours. So thank you, and thank everyone in your organization for existing and doing your job so well.
Mr. Chairman?
Thank you.
Gentleman from California.
Yeah, one last comment as well. We all know that Madame Curie died, right? She died of cancer, I believe, from her experiments, and we didn't even know anything about radiation then at all, and she was the one who discovered this. And about 40 years later, 50 years later, maybe 40, my father had cancer, and he was saved. Radiation saved him. He was one of the first chemotherapy guys, and so Madame Curie died, and my father lived. And we've been through this thing where you go to the shoe store and you're going to buy your shoes. I remember looking in the X-ray machine. So mankind has a lot to learn, and we have learned a lot. And I want to thank you guys for being at the forefront of this important lesson, and trying to see how we can use this to our benefit and take care of the dangers. So thank you very much.
Well, thank you. I want to thank the witnesses for their valuable testimony and the members for their questions. The record will remain open for 2 weeks for additional comments and written questions from members. This hearing is adjourned.
Good, nice work.